Hi friends. Are you facing difficulties while learning data structures? Do you think it is difficult? Don't worry, we have got you covered. We can help you with: what is data structure? Stack. Linked list. Stack using linked list. Data structures is a particular way of storing and organizing data in a computer memory so that it can be used efficiently. There are two types of data structures: primitive and non-primitive. Primitive stores single values: int, char, float. Non-primitive stores set of values: array, stack, linked list. Stack is a linear data structure which follows a particular order in which the operations are performed. The order may be LIFO, last in first out, or FILO, first and last out. It's a list with this restriction that insertion and deletion must be performed only from one end. That we call the top of stack. Insertion in a stack is called push operation and deletion is called pop. To implement a stack using linked list, all we need to do is apply the same chronology to linked list. A linked list is a linear data structure, in which the elements are not stored at contiguous memory locations. The elements in a linked list are linked using pointers. A linked list is a collection of entities that we call nodes. Each node contains two fields, one to store data and another to store the address of the next node. I hope we have covered your basic concepts. Now let's see how stack is implemented using linked list. The address of the first node, that we also call the head node, or start of linked list. A variable stores to address of head node. We often name this variable as head. Unlike arrays, linked lists are not a fixed size, and elements in a linked list are not stored in one contiguous block of memory. We already know how to create a linked list, or insert and delete elements from a linked list. I'm just doing a quick recap here. To insert an element in a linked list, we first create a new node, which is basically blocking some part of memory, to store our data. We can set the data part of the linked list as whatever value we want to add in the list, and then we need to modify the address field of the existing nodes, to link this node in actual list. Now, for a stack we want that insertion and deletion must always happen from the same end. We can use a linked list to stack, if we always insert and delete a node at same end. To insert a node at beginning, we must create a new node. In this example here, once again I have created a new node. Let's say the address of new node is 250. I will insert some data in the first field of this node. So to insert this node at beginning, we just need to build two links. First we need to build this link, so we will set the address here as whatever the address of the current head is, and then we can break this link, and make this guide the new head, by setting its address here, in this variable, named head. To delete a node, in this example here, we will have to first cut this link, and build this link, which will mean resetting the address in this variable head, and then, we can free the memory allocated to this particular node. I want to create a stack of integer, so first field in the node is an integer, another field is pointer to node that will store the address of the next node. I'm defining node as a structure in C. Next thing that I'm doing is I'm declaring a variable named top, which is pointer to node, and initially I'm setting the address in it as null. When top is null our stack is empty. By initializing top as null I'm saying that initially my stack is empty. Now let's write push and pop functions. This is push function. The first thing that we are doing in push function is that we are creating a node using malloc. Push is taking an integer x as argument that must be inserted onto the stack. We are setting the data field in this newly created node. We are dereferencing temp to enter new data. Then we are setting the link part of this newly created node as existing top. This is pop function. If the stack is already empty we can check for the stack is empty or not by checking whether top is null or not. If it's not empty, it must be pointing to the top node. We are setting the address in top as address of the next node. Now using this pointer variable temp, we are freeing memory allocated to the node.